Have you ever wanted to draw the Kenyan flag? Have you ever been curious how you can actually do this with code? Well, in this video, what I'm going to do is take you through the introductory sections of how we're going to get started. So we're going to draw the Kenyan flag and we're going to do it using Python, okay? And we're going to use some interesting libraries as part of the standard library. The goal of this project is to use shapes and actually capture the full detail of the Kenyan flag. Now, in this video, what I'm going to do is I'm going to take you through three important steps. Step number one is we're going to set up the project in PyCharm, and I'm going to push it onto GitHub so that you can get access to the code. My repository is github.com/Paul Courier. It's just my name, Paul Courier. And we're going to have a project there. I'll give it a name. I think it'll be just Kenyan Flag Project or something like that. The next thing we're going to do is we'll spend just a few minutes understanding coordinate systems. And this is where your high school maths will come in handy. Now, I know that a lot of you may not recall this abstract kind of maths that you did in high school. That's fine. It's very, very simple. I promise you, you will find it so simple. And that's going to be really instrumental for our next part. We're just going to introduce how to use the turtle library using what we have picked up from our coordinate system. So let's get started. So the first thing we're going to do is we're going to set up the project in PyCharm. So I'm going to open up PyCharm here. And I'm going to create a new project. Let's say create a new project. And it's going to throw up this screen. And I'm going to give it the name Kenyan Flag. Kenyan Flag Project. Let's call it Kenyan Flag Project. That's a simple name to use. Now I have configured my GitHub, my PyCharm to use Git and GitHub. So if you're interested in how to do that, you can hit me in the comments and let me know that you'd like more information on how to actually set up PyCharm. I always recommend using PyCharm because it's free, and at least there's a free version, fully featured. You can try out the Pro, and even if you pay for the Pro for 1 year and you can't afford to pay for it any more into the future, they leave you with a professional version. It's fully featured. It's really powerful. I would strongly advise you to use PyCharm if you're using Python, especially Python with things like Django, Fast API. All these things come in the box. Now we're going to create a Git repository. We're going to use a project environment. I've installed Python 3.14, which was just released this week. So I'm going to use that. It's going to create for me a project, and I don't want it to create for me any files because I want to show you how to do that. And then we're going to say create. So I will create a new window. Let me just drag that into the view. So there we are. We have our PyCharm set up with our new project. It's set up with Git already, but we don't have any files in it. Now, at the moment, it should be building our interpreter. So it's just concluded setting up our PyCharm with our interpreter. So now we have a virtual environment in that folder, but we have nothing else. So let's do this. Let's create our first file just to make sure that everything works. So we're going to create a Python file here. We'll give it a name, just experiment, just to make sure everything is working correctly. So there we go. We add this to Git, and in this file, I'm going to introduce some code. So what I'm going to do is, let me actually zoom in so that the code is a nice big font. So if I type any code here and import turtle, you can actually see that that works. Okay, good. Now, every time I write code, I always use a standard structure. And I think this is very important to have a discipline of doing this. So in my case, I've set up my PyCharm so that when I type the word main and I hit tab, it automatically populates for me this standard structure. And what this does is it allows my program to return to the operating system a status in the form of an integer. And I have what's called an import guard. This import guard means that if anyone imports this module into their code, it won't run anything. So this is very important. And the next thing is that this is actually essential when you're running certain programs. For example, if you're running multi-processing programs, you need to have this structure. So I've just set this up as a standard template, and I've put it as one of the automatic templates that loads when I type the word main, and it just works every time. Okay, and we're going to import the Turtle library. So now we've set up our project. Let's actually push this to Git and make sure everything's correct. So the first thing, notice the text is in green, which means it's been added but not been committed. So let's commit it. I use Command K and I say this is my initial commit. And I'm going to commit and push. Well, I haven't told it what the repository is. So let's first just commit it. And we're going to make this, so now that is committed, if we come back to the project, we see that the code is, the name of the file is white. And we're using Git. So we're going to push this to GitHub. I'm going to share this project on GitHub, Kenyan project. I'll make it public so that you can actually see it. So it has everything configured for me. It's going to be public. And I'll type here and say we are making the Kenyan flag using Python and the turtle library. Okay, I'm going to share that, and it's going to share that onto GitHub. It's pushing it onto my GitHub, and you'll notice that, okay, then that's done. If I check here in the notifications, it'll say successfully shared. And if I open that in the browser, let's just make sure that this has got enough size. There we are, the Kenyan project, Paul Career, Kenyan Flag Project. And this is the empty file that I've just created. Okay, so we're going to fill it up with time, and we're going to add a lot more information. So let's close the notification. We can keep that open, and we have this here. So that's step one. We have successfully created our Python project within PyCharm, and it's tracked by Git, and it's been pushed to GitHub, and that's great. Now the next thing we need to do is we come back here. So we're done with that first step. I'll give that a tick. Now, let's do some coordinates. Let's learn some coordinates, and we're going to apply this to our drawing. So for this, I have something special prepared. Here, I have a coordinate system that's been set up. And what I want to do on this coordinate system is I want to plot points. But for us to plot points, we have to have some structure. And that's why we have a grid here. So here we have a grid. I have a lovely grid with X and Y. Now, every point along this, we'll say that, for example, this is a value 1, this is a value 2, and this is a value 3, and so on up to the end. And the same thing for Y. We have 1, 2, so that any point along this line will have a value of Y is equals to 2, and any point along this line will have a value of X is equals to 2. So let's just clean that a bit. Just putting that for you to be aware. So if we were to get the value at this point in the middle, this would be 0, 0. So X is 0 and Y is 0. They always go in the order 0, 0. And we call this the origin. So this is the origin with the value 0, 0. Now suppose we wanted to get the value at that point. We would count how many x's there are. So from here it is, so that is 0, and we have 1, 2, 3, 4, 5, 6. So here we have 6, and here we have 1, 2, 3, 4, 5. So this is 5. So we'll start with x, which will be 6, and it will be 5. Okay. So now we have a basic idea of points. Now the same thing happens below 0. We start counting negative. So if we picked this point here, again, we'd start with the x's. It would be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12. So this here is negative 12. And then this one here is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. So that is negative 9. And so this point would be, we start with x, negative 12, negative 9. Okay, and we can go on and on and on and pick points like that. Now suppose we picked a third point. Let's just pick a third point at random. I'll pick a point here. Okay, let's give that point some values. So if we pick that point, let's count what they are. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is 14. And it is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So here is negative 7. So this point here would be x, 14, and y, negative 7. Okay. Now, what if we join these 3 points? So let's try that. So suppose let's change the color here. I'll change this to another color. Let's change this to maybe something that's like purple. Let's see if that works. Okay, good. So if I joined this, if I joined, I think I can use this to draw straight lines. Can I draw straight lines? I'm not sure. But let's just do a rough line. Okay, so we draw a rough line like that to this point, and we drew a rough line like that to that point, and from a rough line like that. Just this is a rough line. So don't forgive me if they're not perfectly straight. We have a triangle, and this triangle has got vertices. Let's call this one A, let's call this one B, and let's call this one C. So A has the points 6, 5. B has the points 14 minus 7. And let's call this C with the points minus 12 minus 9. Okay, so remember, we always start with X, so 1, and then we go to 2. So that every pair is an XY, XY, XY. Okay? Now, what if we put let's put this into practice. Let's do something useful with this. So let's close all this rubbish here and actually open PyCharm. So we come back to PyCharm, and in fact what I'll do is I'll put it here on the side. Now, I want us to see, can we draw this triangle using the library called Turtle? Now, I'm going to introduce Turtle very simply. We won't even go to the documentation. I will say I want to import the Turtle library here, and then I'm going to try and draw. So I will say Turtle, let's start with the first point, Turtle dot, and we're going to go to, the first point is A. So we start with point A, which was 6, 5. And then we will go to turtle dot go to, and we go to the next point, which is 14 minus 7. And then we'll say turtle dot go to, and we'll go, the last point is minus 12 minus 9. Okay. Now, when you do this, we have to tell it, let's see what happens now. So we have, now we're going to commit this, and we're going to push, and we'll say now we are drawing initial with Turtle, and we shall commit and we shall push. So that if you check, it's actually been pushed. But let's run this now. So we can run this by clicking this green here, and let's see what happens. If I click that and I run experiment, it tells me it's running, and it draws something. Actually, it opens something very quickly and closes it. If you try this out, you'll notice it opens and closes so fast that you don't see anything. The reason for that is it needs to wait for you before it can close. So we add an extra line called turtle.mainloop, and so that it can stick and wait for us. So let's just add that. We commit and say added main loop, and we'll commit and push. And so now let's run that. I'm going to run that again. Now it does something. Look at this. So look at what it's done. It's drawn a line, a couple of lines there, and it's got a little arrow. What's going on there? Okay. Now, what's happening is our scale is actually so small that for us to see this clearly, we have to blow this up. Let's say we blow it up by 10 times. Now, to blow it up by 10 times, it means we have to change our coordinate system. Instead of imagining that each of this is 1, each of this from here to here is 1, what if we made it into 10 so that it was actually 10? So if you made it into 10, this will not be 6, it will be 60. This will not be 14, it will be 140. This will not be 9, it will be minus 90. This will not be 5, it will be 50. And so on, 120, this will be 120, 90, and so on and so forth. So our coordinates just change by adding zeros at the back of that. So it becomes 140, 70, 120, 90. So let's change our code again and see what happens. So now we multiply everything by 10. We just add zeros everywhere. One of the cool things about PyCharm is you can actually click everywhere using the Alt key. And you add all these cursors, and then you add zeros, all of them at once. So now if we run that again, so now it draws it, and there, look, that's much bigger. It's 10 times bigger, but it looks funny. It looks funny. It's got funny lines. This doesn't look anything like the triangle we expect on the left. So what's going on here? Well, if I'm going to do this, I'm going to add some extra lines. Let me explain it this way. It's starting off, it always starts off from the origin. So somehow the pen is drawing from the origin to the first triangle. And we need to stop it from doing that. We don't want it to draw that line. We want it to drop that line. And to do that, we have to tell it, stop writing. And to tell it to stop writing, we have to tell it to lift the pen. So we come back here and we tell it, turtle, pen up. So it will go pen up until it reaches its first position. When it gets to its first position, it's going to then start drawing. So we say pen up, go to the first position, and then now pen down. So let's try that. Turtle.pen down. Okay, let's try that again now. If we run that, oh, that's much better. So now it skipped the first line, but doesn't seem to be finishing our triangle. Well, for us to draw a complete triangle, we have to go back to where we started. We start from this point, 60, 50. We go to this point, 40, minus 70. Then we go to this point, which is minus 120, 90. But we have to go back then to the point 60, 50. So let's do that. So just go add this extra line here. Turtle dot go to, let's go back to the beginning. So it will be 60, 50. Okay, so let's run that and see. Ah, there we go. Now we have a complete triangle. We have a complete triangle. Success. Now, what if we put some color? Let's put some color to make this look fun. So once we get to this point, we're going to tell it, why don't you give us some color? So we're going to ask for fill color. Let's say red, okay? And then we're going to tell it, start filling the color. So we say turtle.begin fill. And when it gets to the end, we'll tell it end fill, okay? So turtle.end fill. And we can tell it pen up again, just for the sake of being neat. So let's see what that looks like. Oh, that is amazing. I wish you could see this because it actually does the animation and it draws it if you try this out. So I'm going to commit and push this and you can try it out. So let's commit and push. We say now we can draw a triangle, a red triangle, not just any triangle, a red triangle. I commit and push. Okay, so now we've drawn a red triangle. We've gotten a few ideas. Whenever we draw, we are drawing on a canvas that looks like this. If we start off with naive numbers, it will be too small. So what we want to do is we actually want to then maybe scale things up. Okay, so that's why we had this at the top. We did that. So let's go back to what we wanted to do from the beginning. I want to on this screen, I want to go back to our list of things we needed to do. So we've done number one. We've understood coordinates. Oops, it's got a mirror image. I don't want it to do that. We've done our high school coordinate system. Remember we had x, y, and we've got any point there was just the pair x, y. Some of them were negative. We had our origin. And we've done a very little bit of turtle library. So now what let's do is let's go to the documentation and see a few insights about the turtle library. So the turtle library, if we go to docs.python.org/3/library, and when we go to straight to turtle, you can actually go straight to turtle. It'll show you, it'll give you a lot of details, but it shows you what you can do. And what we've done is we've just looked at a tiny subset of the function. So we've done our goto, we've done a lot of goto, but you can actually draw now shapes properly. And then we've done main loop. If you remember, we had the main loop function. Where is that? Let's just see main loop. I don't see it here. I think it's not one of the drawing methods. These are drawing methods, but you can see the main loop is there. The main loop allows it to at least show up and you can see what happens. So that's a good beginning. And as I said, this is the project is Kenyan Flag Project. Now we're going to build this more and more complex. We'll get to a point where we'll now be drawing very complex shape, but they'll all be built on this. If you now refresh this in your browser, it has all the code from our experiment. Penup, goto, and so on. You can download that and you can try it out in your browser. I strongly advise using PyCharm, which you can get from JetBrains, JetBrains PyCharm, and you can download it from that page, and then you can use it. So thank you for your attention. I hope you enjoyed that. Please stay tuned because we are going to keep going and move on to now drawing proper shapes. Enjoy.